What is up, health enthusiasts? It's Coach Lamby here for Working Weights LLC, your guide to strength, health, and all things nutrition. I am joined, as always, by my co-host, Dwayne Ulrich, aka
Hey,
Poppy Doral.
hey guys.
And today we are going to be talking about lab-grown meat. So, Dwayne, how are you?
You know what? It's a great day in Houston. I'm just basking in the glow of my ring light and the ambient light coming through my window. It's about, 78 degrees here in Houston right now. The sunshine.
Yeah, it's a little chilly here in Cholo, Arizona.
Hey, I made the offer.
Where I was for a second.
I made the offer. I told him I'd wear a couple of coats just for solidarity.
Yeah.
Super excited about today's topic, brother. Super excited.
Yeah, so interesting. So it's another listener requested topic. And so quite frankly, it's pretty new. So we're going to go through it and try and answer what I think. So I looked online on social media and kind of tried to find some of the main questions about it and some of the main arguments against it that people have, and tried to address those as best as I could. So I hope for our listeners, this maybe answers that question. And of course, if you always have more questions about it, you can submit them and I can give you answers that way. You can reach me. I keep forgetting to tell people this at Dustin Lambert at workingweights.com. Dustin Lambert at workingweights.com. And now that I'm on the track of remembering things, Consuelo Health, consuelohealth.com. Go visit Kathy, give a look-see, and talk to her about your healthcare needs.
By the way, you can get a hold of me at Santa at North Pole. No, really.
Yep.
That'll probably get edited out, people, just so you know. So while he's looking how to get out of that, we've had a lot of feedback on our last podcast. I hope you guys tune into that and watch for that one coming out, as well as the one before based on the RDAs and the recommended daily values of nutrition. Excellent podcast. So we've been getting a lot of good feedback on that.
Yes, it seems to be a one of the more popular ones. So, all right, lab-grown meat. It's also known as cultured and cultivated meat. So let's get into the first questions here, which would be, I think most people would be asking, what is it and how is it made? And so discussing how it's made kind of will answer the question of what it is. So what happens is that cells are taken from either a live animal or an animal that's just been slaughtered, and the cells are still viable. And it comes normally in the form of a biopsy. Now, we do biopsies on human beings all the time, so this is of common practice. And a biopsy the size of a grain of rice can result in about 10 million cells. The individual cells for muscle tissue, fat, connective tissue, all these different things are extracted and they're isolated. And then they're put into a culture dish with a nutrient-rich growth medium and allowed to multiply, and they form a primary cell. And this is kind of like swabbing the petri dish with a Q-tip kind of thing that everybody's seen pictures of. They then go on to create immortalized cell lines by introducing specific genetic modifications, or they express specific genes that inhibit the normal process of cell aging, and that's called senescence. Senescence is cell aging and death after a certain number of divisions. Okay, so cells don't just continue to divide and go on forever, but by manipulating some genetic components, we can get cells that will actually go on to do that for a long, long time. Now, the term immortalized is misleading since the cells, they're not actually immortal. they can just continue division for a really long time, much, much longer than we would normally see. And is actually a very common practice in cell biology and tissue engineering to enable long-term studies. So we've been creating immortalized cell lines for quite some time.
Coach, can you make it just a little bit bigger? It's a little bit hard
Oh
to
yeah,
read. That's good. Whoa, 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 back it down.
back it down.
That's good, right there. Whoa,
Okay.
that's good.
All right. We also see examples of this in nature. So germ cells can undergo many cell divisions without experiencing senescence. Stem cells have the capacity for self-renewal and can undergo many cell divisions as well as turn into different types of cells. Hydra are small aquatic organisms and they exhibit negligible senescence. So they kind of just really live for a really long time. And very interesting, I think, is jellyfish don't really seem to age. Some species are even able to revert back to their juvenile form after they reach maturity, essentially restarting their life cycle.
What would do that?
The
That's
jellyfish?
they can go back to their
Yeah. So there's certain species of jellyfish that once they reach maturity, so once you get past the point of reproductive age and you're matured, they can actually revert back to the juvenile stage, which is pre reproductive age, and go through that whole cycle over and over and over.
wow.
Now they
Mind
do,
blown.
yeah, they do at some point die. They're not truly immortal, but these are just examples to show that this manipulation of cells to create
Cell life.
immortalized lines, we do see this in nature.
That's amazing. That's amazing.
All right. Now, not all cells in these cultures are going to immortalize. So the researcher will screen and select specific cells that show signs of continuous division. And the goal is to isolate a cell line that can be perpetually cultured without undergoing senescence. So basically what we're looking for is a cell line that will allow them to create many, many end products that are going to come from the same culture so that they don't have to continually take biopsies, continually go through this process of creating cell cultures, creating immortalized lines, right? So you're looking for something, a line that's going to net the most yield.
So they're not actually engineering anything. They're just looking for the most healthy, the most viable cells. Is that a good way to say
Well,
that?
yeah, so they're kind of doing some genetic modifications to get the cells to immortalize,
Okay.
but not all of the cells are going to do that. So
Okay.
then they're selecting for cells that exhibit those traits. Now, you can't tell that a cell line is going to be immortalized right away. That you're only going to tell that, after so many divisions of the cell line.
Right.
But
Okay.
they're gonna pick those cells that show those specific traits, and they're gonna, as many as they can, and then eventually at some point, you'll find the few that are actually going to give you what it is that you're looking for.
Okay.
And if we think about this in terms of meat production, so what we would really want is to find one cell that's going to last us, let's say, 100 years, right? That we can continue to produce meat from. And that one cell is going to replicate over and over. So the end product is going to be the same end product all the time. So you're creating a very replicable process and a replicable end product. So like McDonald's hamburgers taste the same no matter where you go in the United States, that's kind of
True.
what we're looking for.
I see. Okay.
All right. The cell line is then characterized to ensure it retains the desired properties for meat production, such as the ability to differentiate into muscle cells and generate the desired tissues. So what we want is to find cells that are going to give us the things that we're looking to make, right? If we're looking to make 80-20 ground beef out of this, we want cell lines that's going to produce 80-20 ground beef. Okay. Once an immortalized cell line with the desired characteristics is established, it can be cultured in bioreactors to produce cultivated meat. And this is, so the term bioreactor seems very scary. We're going to go through a little exercise here later to show you that it's not exactly what you think it is, but this kind of resembles the process of making beer. So it looks, the bioreactor that they're talking about looks very, very similar to what you'd see in a brewery, big cylindrical vat looking thing. Once the cells are in the bioreactor, they're put in a growth medium that has all of the basic foods that cells would need to turn into muscles and fats and all that other stuff. And this includes stuff like amino acids, glucose, vitamins, minerals, water, and oxygen. So all the stuff that would be in a living body that would make tissue grow, right?
Yeah.
They
Kind of
can
scaring
then,
me.
is scaring you?
Kind of scaring
Okay.
me.
Okay, good. Let's go. Okay, so they can then either allow the cells to attach to a scaffolding and create a muscle tissue in the shape of something. So if we wanted to create something that was in the shape of a chicken breast, they can actually put a form type of scaffolding that the tissues then connect to, and the end result would be a chicken breast, right? A formed chicken breast. Or what you kind of get if you just let everything produce on its own, you get kind of this ground beef textured stuff, and that's formed into patties and sausages and hot dogs, and can be formed into chicken breasts and other things like that. And so far, what I think is being worked on, so what's kind of available right now is chicken, beef, and salmon. The salmon may not be publicly available; they may still be, but I've definitely seen videos where they kind of have an end product that they're putting, they're using to put in sushi to kind of introduce into the public. And they're working on producing things like organs, milk, and eventually probably going to see eggs and different other animal products. Okay, so what this is it is muscle cells that are taken from an animal. The cells are grown in a medium of the same nutrients that animal would be eating. And the process is the same process that happens in the animal's body. It's just artificially controlled. It's controlled by man. And the end result is the same tissue that was grown on that animal, and it is identical right down to the cellular level. So when I say that they are producing a chicken breast, it is molecularly and cellularly identical to conventional chicken breast that came off of an actual chicken. Let's see your brain working. Tell me what you think.
Man, I don't know. Let me get my tinfoil hat because it's going to be necessary right now. Just so, man, it's not cloning, but I was okay until you talked about, working on organs, possibly eggs at some point, and salmon, and that threw me. I don't know why. I think salmon would be easier and less benign. That's not the right word, but less extraordinary than beef. And I understand the science you just told me. I'm just weirded out about it. But by the same token, I'm weirded out about a McDonald's hamburger, and they all taste the same no matter where you go. So they look the same. Their texture is the same. It's just the same everywhere you go. I can't say that I like them, but
yeah. So if we think about it that way, like McDonald's kind of has their own line of cattle. They don't just buy beef from anyone.
Yes.
Right. They have their own line of cattle, and that helps with that reproducibility of the end product, the final taste. The cattle are all raised the same way. They're all fed the same stuff. The whole process of doing that is the same. They buy all of their wheat for their buns and everything from the same places.
They buy their potatoes from the same guy.
Right. And so the way that this cultured meat, so it's the same process of creating an animal tissue. It's the same process. It's just being artificially controlled in a bioreactor rather than in nature. Okay. And the end result is the same thing. Chicken is still chicken. It's the same chicken breast. So it's the cells taken from an actual chicken. And so to think about it, it's kind of like cloning the chicken breast that cell was taken from.
But
So
sort of, but not
it's a
really.
sort of, but not really. Yeah. It is new tissue. It's not an exact clone, but it's animal tissue cells, right? So it's not a
What about the growth period? So, for example,
mhm.
um, okay, so I choose not to be very intelligent about the life cycle of a chicken. I was
Yeah.
around chickens a lot as a kid, but yeah, anyway, I've gone past that. And so, the life cycle of a chicken to grow a viable chicken breast
Hmm.
for sale or for consumption, or for that matter, um, a beef patty through this process. What's the timeline? Is there an acceleration factor anywhere? I mean,
Yeah, so it's extremely accelerated because you're not growing the whole animal, right? You are only growing so a chicken, it takes 6 weeks to grow a broiler chicken ready for slaughter.
okay,
And
okay.
that I think should alarm some people.
It
Okay.
kind of does. It
It
kind
takes
of
six
does.
weeks.
Yeah,
Through the
it kind of
process
does.
of cultured cells, of making cultured meat, you can produce a chicken breast in about 2 weeks. So we don't have to grow feathers, we don't have to grow legs, we don't have to grow a beak and eyeballs, a tongue, a digestive system, a circulatory system.
Right, right.
You're starting with one cell and you're creating a chicken breast. So
Okay, and
the amount of time it takes is drastically reduced.
okay, and another thing then to think about also is that, uh, and this isn't like critical, but is you're not just growing one chicken patty or one chicken breast, or you're not just growing one beef patty in these reactors.
Hmm.
Because
Yeah,
if it's large, you can grow probably hundreds or thousands of these things.
yeah. So there are different companies producing it around the world. And in the United States, we have Upside Foods and Good Food Industries. And I think Upside Foods probably has the largest bioreactor where they may be able to produce, I want to say, tens of thousands of pounds per year.
Wow.
And so they are working on producing up to 500,000 pounds of meat per year. And then Good Foods, I think that they're a little bit smaller of an operation. And they're maybe in the hundreds to thousands of pounds per year.
That's still massive.
Yeah, still a lot of meat. So if you think about a cow that's raised for beef, a beef cow, not a dairy cow. So the average weight of those it's like 1,400 pounds.
Hmm.
And what we get out of that is like maybe 450 pounds
Right,
of usable meat. And it takes, roughly a year to get a cow that big
right.
to grow it ready for slaughter. And so they're able to produce the same amount of beef in a couple months.
That's amazing. That's just amazing. I'm sitting here looking at the upside the Upside Foods bioreactor right there.
Yeah, yeah.
Looks kind of like a nuclear reactor to me. Just saying. I'm sorry. That's amazing stuff, man. That's crazy.
Camera. Yeah.
That's amazing, dude. That's amazing.
So there was the world's first cultivated meat blind tasting. So this is chicken. Okay, so they're comparing cultivated chicken to conventional chicken.
Hey everybody, I'm here at Super Meets the Chicken where we are hosting a monumental event. Today we'll answer the biggest question consumers have about cultivated meat. Will I be able to tell the difference? We're conducting a blind tasting of 100% cultivated chicken meat compared side by side with 100% traditionally grown chicken. The blind tasting will be conducted by 3 judges: Chef Yair Yosefi, Channel 12 news reporter Leah Abramovich, and gastronomist, food journalist, and MasterChef judge Michal Ams. Each judge received 2 samples that were prepared in the same way and without any seasoning or additives. Let's see what the results are.
I wrote down that there's a difference between them, but I wouldn't be sure which one is the chicken, which is nice, very nice. I would say these the chicken, maybe.
So the first thing that caught my eyes is the color. The color is different. Both felt like chicken. If you ask me which one I like more, this one I like more.
Okay, thank you.
I would say that it's remarkable because they're both very similar. I cannot detect who the real chicken is. If I would have to bet, I would say that B is the cultivated chicken.
A is the cultivated chicken, and B is the chicken fillet that were slaughtered and grown.
And I was wrong.
You were wrong in this case?
I was so sure that this is the real chicken. Now I'm confused.
I've heard of the chef before. I know who that guy is. I mean, not personally. We don't hang out, play golf, but his reputation, I mean, is significant. So the fact that he really couldn't tell, he knew there was some kind of taste difference, but he couldn't tell, and neither one of the samples offended him. So that's telling to me that a chef of his stature couldn't really tell which was which.
So the lady on the far right was a master chef judge, and she thought that the cultured meat was the real chicken.
Yeah.
She was
That's
absolutely
amazing.
sure. And then the lady in the middle said she actually liked the cultured chicken more than the conventional chicken.
Right. That's amazing. You know, just if I probably shouldn't labor this because we have a lot more territory to cover, but if you think about it, in any animal, things like stress, external factors, heat, temperature of the climate, how much water they get, all of those things become a factor in their growth as well as the taste of the meat. Like if you're a hunter, you know, if you're eating, you know, venison or deer meat, or for that matter, pork, or even turkey, or, you know, fowl like duck, their environment triggers certain things in their bodies, which will, I don't want to use the word taint in a bad way, but it'll taint the flavor of their meat, such as like a gaminess or more or less of a gaminess. So that's one thing that could be really, of course, some people like that, but those variations, but that would be something that's completely controllable in a bioreactor. And I like the fact that it's not cloning per se, but yeah, okay.
Yeah. So dealing with the taste with the salmon, so the videos I watched with the salmon is that they described the taste of it to be oceanic but not fishy. So they actually kind of lost that fishiness that puts off a lot of people, and they just kind of seem to be like they just used the word oceanic. It was just kind of like an oceany type of flavor instead of a fishy.
Well, and fishiness is also part of the, you know, the environmental impact on their system.
All right, so let's talk about some of the common objections. And I think I narrowed it down. So there's lots and lots of different opinions on this online. And so I think I narrowed them down to the kind of the main points that people are trying to get at. So one thing that people, there actually was a quite a large misinformation spreading that happened when the FDA first approved these 2 companies. And so people are saying that these are cancer cells, or you're actually eating tumors. And so the comparison comes from the immortalization of the cells. So cancer cells have the same, resistant to senescence, or they're negligibly senescent. They kind of divide for a really, really long time before they end up dying. And so that's where the comparison comes from. However, there's several hallmark characteristics of cancer. Immortalization is just one of them. And so those characteristics that make cancer cancer, you actually wouldn't want those when you're trying to create a process of producing the exact same product repeatedly and reliably. And so one of those characteristics would be uncontrolled growth, right? We want to control kind of how much meat tissue versus fat tissue versus connective tissue versus all of these different things that go into making a meat, which is going to result in mouthfeel, texture, flavor, nutritional profiles. We want to control all of that. So to have uncontrolled growth in any one of those aspects would be undesirable when we're trying to create this product, right? Unexpected development as well. Cancer is just an umbrella term for a category, a type of disease. There's over 200 different types of melanomas. And so when we find precancerous cells or a precancerous tumor or something like that, there's no way of knowing what type of cancer that's going to turn into. All right. And so that's something we don't want as well. So if we're trying to create 80/20 beef and we end up getting a hoof, that would be very bad to the bottom line, right? We want to know what it's going to turn into.
Yeah, you missed the turn at the beginning.
And so cancer also seems to be very, very resistant to immune system or germ destruction. So cancer is very, very hard to kill. In fact, you almost have to kill the host in order to kill the cancer. And so the same people that are making that argument that this is cancer are the same people who will say, well, a single microbe or germ or virus can infect an entire bioreactor and spoil the whole lot of meat. So we shouldn't be reliably looking to cultured meat as a food source. Now, when you think about this logically, it doesn't make sense. You can't at one point claim that this is cancer and then also claim that a single microbe is going to spoil a whole lot. The two just don't pan out, right? Because if it was cancer, it would be extremely resistant to those germs.
True.
A single germ in that vat wouldn't make one iota of a difference. But if it does, and it can spoil that lot or end up killing some of those cells, it can't possibly be cancer, right? Because it's not very resistant to that bacteria.
Okay. I'm with you. Yep.
So on the basis that it's cancer there, it's just not, it isn't cancer. It just doesn't fit the hallmarks of cancer. That being said, consuming cancer cells wouldn't even be a food safety issue. So the cells are going to be dead by the time you eat them. Americans consume about 265 pounds of meat and about 245 eggs per person every year, right? This is the average. And these are from living animals, and they get sick, they age, they also develop precancerous cells that you wouldn't see without a microscope, right? So by the time you slaughter the animal, cut it up into the cuts that you want, put it through the whole processing system before it gets to you, then you bring it home and then you cook it. Whatever precancerous cells, and people, there are precancerous cells in the tissues that you're eating. Okay.
Well, I never thought of that. I'm sorry to cut you off. I never thought about that, but it's naive to think that the food that we get is completely free
right
of precancerous cells. I mean,
now it doesn't have. I don't want.
Go ahead. I was just going to say precancerous cells occur even in animals, so it's naive to say that that we're not consuming that.
Yeah, and I don't want somebody to take that to this wild conclusion that you're eating cancer or you're eating tumors, because you're not. Because if an animal was to have cancer or tumor, or they would find this at some point, and that meat or that animal would be removed. If you found it in the animal, if an animal was diagnosed with cancer before it made it to slaughter, they would just euthanize it and probably
Yes.
just bury it or
Yes.
whatever the
Yeah.
case is, but it's not going to end up in the food supply. But
Yeah.
we all have precancerous cells in us. These animals all have precancerous cells in us. So the issue of, if this stuff was actually cancer, you're already eating cancer cells, right? It's already there.
Yeah.
Okay.
Yeah.
Now,
Yeah.
this actually speaks to the benefit of cultured meat because the process of growth is highly controlled. Remember, this isn't happening in the natural environment. This is
Right.
artificially controlled by man. We control what's happening in there. So there isn't a chance for cancer cells to develop. We go
Right.
from a single cell to an end product in about 2 weeks.
Right.
Okay. Not only that, but the controlled environment prevents the development and transmission of foodborne illnesses like E. coli, salmonella, tapeworm, listeria, botulism, norovirus, swine flu, avian flu, and campylobacter, just to name a few things. Okay.
Mhm.
So this cultured meat is actually a safer food in our supply system because it is so highly controlled. All right. Another objection is the fecal bovine serum. Now, when the FDA approved what the FDA approved is the process to make these things. And so during that process, these two companies submitted both a serum and a serum-free process. Okay. Now, everyone is trying to work at getting away from this serum process because, number one, people, kind of have some issues with using fecal bovine serum. We're going to talk about what it is and all that stuff. And then, number two, a lot of these guys are doing this based on ethical reasons. And so where we get fecal bovine serum from, they want to reduce that overall as well. And the whole idea is, well, let's try to make meat and milk and other dairy products to replace the conventional agriculture sources that we're getting, or some portion of it. So where we get fecal bovine serum from is actually from pregnant dairy cows that are just too old to use anymore, or they don't produce enough milk. And so when a dairy cow is done producing dairy, it ends up going to slaughter. Sometimes you get a cow that's pregnant. And so when that happens, then what they'll do is they'll extract the fecal bovine serum. And this is kind of like, it is not the cells of the fetus. This is more like the amniotic fluid in which the cells start the process of creating a baby cow. So that serum, that fluid, seems to be a medium that all cells just really, really like to be in. And it's very easy to create the growth that we're looking for. And so that's why they use it. So it's actually a byproduct of the dairy industry. It's not a byproduct of anything, specifically regarding cultured meat. It's actually used far, far more in medical and pharmaceutical industries to culture cells. And again, the cultured meat side is trying to get away from it. They do have processes that are serum free. It's just a little bit harder to do, and so it's a continually working on thing. So right now the FDA approved both processes, and these companies did it just to kind of get the ball moving on getting the process approved, right? And so they're going to continue to refine these things and get away from the serum. All right, so we're going to move on to the next one. This seems to be this is the biggest one here, which is the general fear of something new or fear due to lack of knowledge. And this is actually called food neophobia. All right. Now, the arguments that are made in this category break down into several logical fallacies. Number one being an appeal to tradition, right? So we've always eaten animals, therefore we should continue to eat animals. Now, just because something's been done a certain way for a long, long time doesn't necessarily make it right or justified. And a couple examples would be slavery and child labor. Okay.
True.
We also have the appeal from incredulity, which means I can't understand how X can be true, therefore it isn't true. right? So a lot of arguments kind of result in, I don't know how this could possibly be health promoting in people, therefore it's not going to be. All right. We have an appeal from fear, which is expressing concerns about the unknown aspects of a new food and emphasizing potential risks without concrete evidence can play on people's fears and emotions rather than presenting a rational argument. We have a slippery slope fallacy. Okay. So because we don't know certain things about cultured meat, it will inevitably lead to bad outcomes. So the fact that we don't know things is just proof that it will be bad. We also have an appeal to nature. So it's not natural, and we should only eat natural things. And I think this is probably the most common argument that I saw. I'm not going to eat anything that comes from a lab because it's not natural. So we have a lot of things that are natural, like lead, cyanide, and arsenic. And I don't hear anyone recommending that we consume those things.
Right.
All right. I want to introduce also this concept. It's called antagonistic pleiotropy. Now, pleiotropy is a genetic adaptation to an environmental stressor, which would make that organism resistant to that stressor. So a good example of this would be kind of like heat tolerant people. So if people grew up in the middle of Africa, where it's really, really hot, the sun is out most of the time, you're exposed to those rays, you're exposed to that heat. After many generations, we would start to see a genetic adaptation where those people become resistant to the heat, right? They're more heat tolerable, they're more sun tolerable, they're more drought tolerable, they require less water, they require less all that stuff. Now, that same adaptation, which gives them an advantage in a hot climate, predisposes them to more susceptibility from a cold environment. Okay. So a genetic adaptation that would make you resistant to heat makes you more susceptible to the cold. And then some other things, so some actual things that we look at, sickle cell. So sickle cell actually produces, I can't think of the right terms, but anyways, this is protective of malaria. Sickle cell actually protects the host from malaria. However, right, it doesn't end up being terribly good for your long-term health. Right. Crohn's disease is another example, and there are several autoimmune conditions. Interesting finding here in this, Crohn's disease actually stems from the bubonic plague. Yeah.
Really?
Yeah. So if you have Crohn's disease, or you have someone in your family that has Crohn's disease, there's a very, very high likelihood that you have an ancestor somewhere along the way who survived the plague.
Wow.
That's crazy to think about, huh?
So that's generational, passed down to generations. So does it skip a generation, I wonder?
I'm not sure. I'm not sure how it works.
But that trait is always there in that line.
Yep. They've traced Crohn's back to the bubonic plague, and there, like I said, there's other autoimmune diseases related too. So these very things that are causing a lot of health issues for people today helped their ancestors survive the plague. Okay. Now, how does this fit in to cultured meat? So if we compare two foods, and let's say that those foods provide the same, they're nutritionally equivalent to get an organism to the age of reproducibility. Okay, so they're both equal in getting you to the age of reproduction. The one that is new, right, the one that you have not been eating for generations, we can a priori deduct that it would be more beneficial for long-term health, specifically because those adaptations, right? So I think a common argument is that, well, we've eaten meat and everything so long, specifically from live animals, that we are just adapted to eat it. And I think that that's true. However, as we've gone through some research in past episodes, those adaptations to that food, which may help us get to reproductive age, don't necessarily help us in long-term health. right? So we see the example would be red meat. So I don't think there's any argument that can be made that we haven't eaten red meat for a long, long time, and that we have specific adaptations to consuming that and digesting it and utilizing all of those nutrients. But it turns out the people who consume the most red meat generally have the most health problems and die the earliest.
Yeah, we've proven that many times. Wow.
So the concept of a red meat that would come from an animal versus a red meat that would come from a cultured process, we can, going off of the concept of antagonistic pleiotropy, we can assume that the cultured meat would be better for long-term health. All right. Some other things for the general fear of something new. Now we have these two companies in the US that are approved by the FDA right now. Both of those companies have glass walls. You can actually go to Upside Food or Good Food Industries and look at everything. You can talk to everyone. Everyone is very open. You can see the whole process. Okay, so if you wanted to know, if you actually really wanted to know, you could go there. You could see the whole thing happening. All right, so another argument along this line is, well, this is new technology. This is new stuff, and there's no way of knowing what's going to happen. Well, that's not true, because as we've gone through, we've been creating cultured tissues and organs in the medical and pharmaceutical fields for decades now. I remember being a kid and seeing the ears that are being grown in petri dishes.
I do not remember that.
You don't remember that?
No.
All right, let me share.
Oh my gosh, you're gonna show me. Don't show me, please. Oh, you gotta be kidding me.
Boom, here we go. So we've been growing tissues and organs and stuff for a really, really long time. That's fake. That brain one there is fake. Let me see if I can get up here. Yeah, so here we have this is a liver, a cultivated liver. This is grown from a cell. We have a complete working system here. The liver. Here you have lungs, a heart, and I think this is a pancreas or a spleen or something. You have an entire limb, right? So this is a rat or a mouse or something that grew that entire limb. We have lab-grown capillaries. So not only do we have lab-grown veins, but you have the lab-grown capillaries. This is not new.
I'm completely freaked out. It's a brave new world, people.
It is a brave new world.
I would
All
like
right.
to say this, though, before we move on.
Yeah.
So in the bioreactor, at some point in the cell selection, they should be able to control the amount of fat.
Yes, we're going to get into that.
Okay, good, because that's
yeah, we'll talk about that.
That's a plus. Okay.
Yeah, so our one of our last arguments here, we can't really know everything about cells or genes and everything that plays a part in nutrition from our food. So there, I heard a lot of arguments about how there are known aspects to nutrition and there are unknown aspects. So like in plants, we have all of these phytochemicals and phytonutrients, and they don't really they're not vitamins, they're not minerals. We kind of don't know what they are, but they're beneficial to us. And the same thing is coming from meats. And it's like, well, do we really know enough about all of these different cells to be creating this stuff? And so, I have one rebuttal. There was a sheep named Dolly that was cloned in 1996. It is a living, breathing, food-consuming, defecating animal. That entire being, okay, so a sheep with 4 legs, hair, teeth, a tongue, eyeballs, a working circulatory system, a working respiratory system. It eats, it craps, it has skin, it has muscles, it moves around, it thinks on its own. That entire thing was cloned from a single cell.
I remember that.
Right. And we have many animals that have been cloned since then. They have stopped kind of focusing on the cloning and everything is shifting more to gene editing now, because so the cloning thing just wasn't working out very well.
If nothing else, there are ethical issues.
Yeah, ethical issues there too. All right. So the idea that we don't know enough to be doing this, we have created entire living organisms from a single cultivated cell.
Right.
Okay. So they're kind of aware of what they're doing.
Wow.
All right. So, Dwayne, you keep talking about the bioreactors.
Yeah.
And when we think about lab-grown meat, the term lab-grown meat, it kind of puts an image in our mind of a sterile environment, people in white lab coats, right, with masks and hairnets and everything, and a really kind of like just sci-fi looking thing where we wouldn't expect food to come from. So we're going to play a little game.
Okay.
And this game is called Which One is the Cultured Meat?
Okay.
It's very short. All right. You see that?
Yes.
Okay. So we have a picture on the top, picture on the bottom. One of those facilities produces cultured meat. Do you know which one it is?
The one on the bottom.
No. That is a meat packing facility.
Okay. Is the one on top a beer factory?
The one on top is cultured meat.
No way. Really?
Yeah. Yeah. And so in both
Wow.
images, we can see that there are men in white lab coats wearing hairnets, safety glasses. The guy on top has I guess this would be a hairnet for his beard or whatever, right? But both facilities look very laboratory-like. One produces cultured meat. The other is actually a meat packing facility. All right. Picture on top, picture on bottom. One of those facilities produces cultured meat. The other produces butter.
The one on the bottom is cultured meat.
No, that is the butter.
Get out of here. Come on. Come on, man.
I promise.
I hate losing.
All right, last one. One of these facilities produces cultured meat. One of these facilities is a dairy production facility. Oh, I think I have one more, actually.
The one on bottom is cultured meat.
The one on bottom is cultured meat. Last but not least, one of these facilities produces cultured meat and the other produces beer.
The one on the bottom is cultured meat.
Correct. That vat is easily recognizable once you learn it from the first picture. Huh?
I'm back on track, baby. I made a 50 on the course.
All right. So there you go. So in terms of scary lab, I mean, I think this is a good example as well as like how far removed people are from the actual source of their food. Not only, are there people who don't really understand that an animal has to be killed and processed and cut up into, bits and produced, to make a chicken nugget, what it takes to make a chicken nugget. I don't think people understand the whole process that gets there, but then also just, what it takes to produce butter or dairy or just these simple things that we take for granted, just how far people are removed. And so you hear these arguments, well, I'll never eat anything from a lab. It's like, well,
we already do.
Define what the lab is.
Yeah, we already do. For me, I think the hardest pill for me to swallow it was probably at the beginning in the cell selection, because once it gets into the vat, it's kind of like fermentation almost. I mean, that's so much easier to accept because there's no weird magic going on in there. Basically you're growing some cells in a petri dish. You do that with you do that with homemade bread that's sitting on the table until it grows some penicillin. Or you've got your onions in the pantry and they let them sit down there too long and they've sprouted. So that's not the part that threw. Yeah, that's the part that doesn't throw me is in the vat or in the bioreactor. I think the part that had me kind of thrown for a loop is in the cell selection. And the other part that threw me was in the bioreactor, the mesh or the framework that the cells attach to begin the growth there. It's
Mhm.
like the mesh is like the bread that the penicillin starts growing on, So
Yeah.
yeah, I'm more okay with that now, seeing it and seeing, gosh, it really threw me, the whole thing about the even though I got it right, the difference between a dairy and the bioreactor. It's like it's kind of the same almost,
Yeah.
but yeah,
Some of
I'm
these, arguments against it, or the fear of the unknown, we really don't use that same logic for a lot of other places in our life, and one of those places is medicine.
oh my gosh, yeah,
The idea that the average person knows everything about chemotherapy or synthetic insulin or many of these life-saving medicines, people don't know what's in those things. You have no
yeah,
idea how that stuff is made. But I
yeah,
guarantee you, if you got cancer or you developed diabetes that required insulin, your objection isn't going to be, well, I don't know what that is.
yeah,
You're going to want to save your
yeah,
life, right?
yeah. Wait, I
Um,
want to throw this in there for
yeah.
that too. I'm not trying to open a barrel here, so let's not go down that hole. But look how easy it was for the global community to take vaccines.
Mhm.
They were untested. They had not gone through all trials that are normally done for any kind of medication, and we just did it. Boom, we just did it. And we
Mhm.
don't know what's in there. People don't
Mhm.
understand what
Yeah.
mRNA is. They have no clue.
Right. Yeah.
So that's that. I think that applies directly to this.
Mhm. Yeah. And yeah. I mean, that can go for any for flu vaccines.
Yes.
You go to the doctor, and your doctor, you have with the sniffles, and your doctor prescribes you a medicine. You don't question
Chemotherapy.
how that.
Yeah.
Yeah, you don't
Yeah.
question how that stuff was made, what's in it,
Yeah.
where it came from.
Yeah. Yeah.
Um, all right. So going on to some of the benefits. So we talked about being able to control the amount of fat that's in there and all this stuff. So yes, absolutely. They have perfect control over that. And they're really, really working on developing the ability to fine tune the nutritional profiles of these things. And so when we get into the aspect of red meat, so we've discussed that. And so, two of the major things that are the thought about problems would be saturated fat and heme iron. So
Oh
if you
my
think
gosh,
about,
you could lower cholesterol.
you could lower the amount of saturated fat in there, you could lower the amount of
Wow.
cholesterol, you could lower the amount of heme iron, you could add other types of iron to it so that the iron content is the same. It's just that the heme iron would be lower, and we could actually increase the amount of omega-3s in here. So
Wow.
if you think about if you were to get a ribeye that is now 1% saturated fat, 10% omega-3, and 5% omega-6. So it's, the fatty acid composition of it would be nutritionally optimal. And it
I
would
would
still
love.
have the same mouthfeel. It would still have the flavor might be a little bit different and maybe off, but you would have a ribeye that is now extremely like as health promoting as a fillet of salmon is.
I would love to know how that tastes. I would try that. I would love to know how that tastes.
Mm-hmm.
Wow.
So we could increase the poly and monounsaturated fats within these things, reduce the amount of saturated fat, and if you are either pro or against saturated fat, I don't know that anybody's really against saturated fat. Well, maybe some people are vehemently, but diet just seems to be like that. But if you were very either camp, I'm not really sure why you wouldn't want this meat to come out and to be developed where we are manipulating the amount of saturated fat within, because now we could actually start doing the testing, the trials that people want done, right? So we can randomize people to a group that consumes red meat from conventional animal sources, and then we could randomize, the other group to this cultured meat that is low in saturated fat, high in all these other things, omega-3 and omega-6, and we can actually look at what happens between those two groups now, instead of red meat versus beans or lentils, or red meat versus plant-based meat, right? It would be red meat versus red meat, and the only difference that we're having here is the amount of saturated fat within it. The total amount of fat would be the same. The saturated fat content would be different.
Wow.
All right. So there are several environmental benefits to this. According to a life cycle analysis done by the good food industry. So by the year 2030, and this is the big caveat here, using renewable energy sources, cultured meat processes would decrease the carbon footprint by 92% compared to beef, 44% compared to pork, and it would be comparable to chicken. It would be about 3% higher. It would reduce greenhouse gas emissions by 94% compared to beef, 42% compared to pork, and 20% compared to chicken. It would reduce land use by 90% compared to beef, 67% compared to pork, and 64% compared to chicken. And then there's another one of these food companies that's overseas called Masa Food, and they estimate to be a 96% less water consumption compared to just blanketed livestock agriculture. We do have several studies, so not just this one by the good food industry, on these life cycle assessments of cultured meat compared to conventional agriculture. Now, there are limitations to these life cycle assessments, and the big one being that these are basically comes down to estimated guesses, right? These are predictions.
Mm-hmm.
So we don't know for sure. Okay, so there are limitations to it. There are several of them done. It's kind of scarce right now because all of this stuff is in the works of getting approved. I think the only place that has been approved for a little while has been Singapore. So we're just getting it in the United States. And so it's still relatively expensive. So the first hamburger patty that was cultivated, I think, cost $300,000. A quarter-pound patty was $300,000, and it's down to $11 now. Okay, so compared to a quarter-pound patty of beef from conventional sources, now conventional agriculture is subsidized. So if you were to remove those subsidies, we would find that as it stands right now, those prices would be quite comparable. Or if you were to provide subsidies to the cultured meat industry, those prices could get very comparable. But they are continually working on these processes and how to increase the yield from, all these lines they're working on. So the nutrient sources that they add to it, so the carbohydrate and water and everything, all this stuff has to be very, very clean. What's the word I'm looking for? Sterile, right? And so the way that they're sourcing these things right now, that medium to grow the cells in is quite expensive, and so they're looking at other avenues to increase production of that yield and to make it cheaper, so that would bring the whole cost of everything down. We have ethical considerations here. This is no-kill meat. If there's something I think everyone can agree on, it's probably that we all could agree that factory farming is probably not the greatest thing that we could be doing to animals. Cramming them all into tight spaces, and we have to pump them full of antibiotics because they're living so close to each other, so they're passing germs and viruses and stuff. And so if we could reduce the amount of meat needed from, factory farming, that would improve animal welfare a whole bunch. If reducing the amount of factory farming, we're freeing up a whole bunch of land in this process. And so if you really, really like pasture-raised regenerative sources of meats, you would be freeing up more space for that type of farming and that type of agriculture to be happening. All right. We would also have more land to be planting non-grain products. So everybody seems to have a problem with all the amount of corn, wheat, soy, and all that stuff that we're growing. Well, if we free up a bunch of land that these conventional meat sources are being grown on, that's land that we can then go and plant some fruits and vegetables on. And then at the end here, I kind of find the arguments against the ethical considerations boil down to, well, I just like meat. I just like the meat from animals. I think that that's kind of what it boils down to. I may be wrong there. But when I'm hearing people make their arguments online and I'm reading conversations about it in social media and stuff, that's really what it comes down to. And I kind of find that to be just it seems to be kind of like a culture of death, especially regarding red meat. People are very, very emotional around red meat. And when it boils down to it, it just kind of like they want everyone to be consuming red meat. We need to consume more of it, less chicken, less pork, more beef, all this stuff. And it just boils down to, I just like it, and I don't really have a problem with killing animals to get it. And like I say, it just that just kind of seems like a culture of death.
I understand what you're saying.
Mm.
I'm not quite there with you. I don't think I'm a harbinger of death, but I'm not quite there completely. And
yeah, so if we were to
by the way,
say,
we talk about chicken so much, and all, also fish and those things, and then we kind of demonize, taking meat from cows or lamb or goat or pig, any red meat. We kind of have to put that same, for this conversation, we should have to put those same caveats on fish and chicken. We'd have to put that on everything without, to be even across the board.
mm-hmm.
And then, so I'm not there. I'm not ready to go down that hole yet.
So the question,
I get it, but
yeah.
I'm not ready to go there yet.
Yeah. So the question would boil down to, not specifically for you, but so a lot of the arguments that I'm seeing online is, having gone through all the information that we did, right? So what is it? Where does it come from? What are some of the answers to the main issues that people have with it? You get to all of that, and then you come to the question, okay, we can produce meat without killing animals, right? So let's say that we could snap our fingers tomorrow and cultured meat could replace every bit of meat and animal products that we're getting in our grocery stores. If we could do that without killing animals, what then is the argument against it?
Well, I think that that would be great. First of all, I think it'd be great that we could do that, and especially if it's, if we can nutritionally enhance the cultured meat, that would be amazing for our health, etc. But I'm not coming out of left field with this. There's an eco balance that is in the world, and since I can't really speak for countries across the pond, just in the United States, there's an eco balance. So, for example, the explosion in the growth rate of feral hogs, and people go, "Oh, that's it's a real thing," and the result of the explosion in the feral hog population is billions of dollars of loss in corn and other farm crops.
Mm-hmm.
And I think we all agree that, eating corn is not like killing an animal, but you have a exploding population of animals that are destroying. I mean, when you talk about billions of dollars of corn crop,
Mm-hmm.
that's a lot of territory, and that's a huge chunk out of the food lineage that winds up on our shelves at the grocery store. So there's some issues there, I think, that are worth talking about or worth thinking about in the future, or
Well,
You know,
so but
out,
what did any of that have to do?
maybe outside of this conversation. What does that have to do with us eating meat or what?
Yeah, so to answer the question, if we could procure all of our animal sources of foods without killing animals, what is the argument against doing that?
Well, like I said, um,
I'm just
I
not really
wouldn't.
sure where feral hogs
Well, the feral hogs is
answers
just an
that question.
example. Feral hogs is just an example.
Yeah,
So
but we don't eat feral
cat.
hogs.
Well, some people do, but the point being is,
Yeah, but not in the
it,
grocery store. So my point is the food in the
no.
grocery store. Not we're not talking about hunting or any of that stuff. So you go to the grocery store, you buy milk, eggs, cheese, and chicken thighs and hamburger.
Okay.
If we can do that, if we can provide all of those things without killing animals, what is the argument against it?
Nutritionally, I don't really have an argument against it. However, I'm going back to the fact that way back in the, let's go back to the fields. You haven't. I just, this could be a ridiculous argument, but going back to the fields, cows are going to keep proliferating. Hogs are proliferating. Deer are proliferating. Chickens are proliferating.
No. Hold on. The only reason we have cows and chickens is because we breed them into existence.
I kind of beg to differ with that.
So the dairy cows that are on the farms, the Angus beef that is raised specifically for, to be slaughtered by beef. So the animals that are contributing to our food supply, like the stuff you buy at the groceries, you are saying that those animals are found in the wild in a natural state somewhere?
They are now.
Broiler chickens?
Yeah. Chickens are all over the place. They even if they weren't naturally in the wild and they've been bred, people aren't always good keepers of their animals, and so there are broiler chickens in the wild now that some survive and some don't, but they were just let out.
They come
just
from
set free. They were set free.
right,
They're
both.
set free from
Okay,
people's farms. Who,
so we're starting
for
that
example,
in the middle of the book. Where did that chicken come from?
Well,
someone had to breed it into existence.
Well, we did, but we can't go back and change that. Oh, we shouldn't do that. Let's don't do any more of them. They're not just going to magically disappear. So man have made mistakes in the past, and obviously we'll keep making mistakes in the future. But I mean, do you just the feral hog situation in the United States? I hate to keep going back to that, but I'm pretty familiar with it. So do we even know where feral hogs came from?
Yeah, they came from domesticated hogs.
Yes and no. So feral hogs are typically more aggressive than like farm handled hogs and pigs. And there was some interbreeding done back in the day. And I'm not going to go off into the whole situation, but with a European hog that was much more aggressive, and then certain farmers just let them out and they breed like fleas, I guess. But so now we still have those. Now that's proliferating out in the wild. Well, yeah. So a lot of people don't eat those things, but they're going to continue to proliferate. Okay. So we can't just go back and say, oh, let's stop, and it all goes away, or that the population stays the same.
So the argument against cultivated meat. Hold on. The argument against moving our entire food supply to a no-kill method of obtaining meat is that these animals will exist in the wild?
These animals do exist in the wild. Okay. I'm not saying that cultured meat's a bad thing. I'm just saying that okay, well that'll create another problem for us in the future that we may have to look at.
What's wrong with allowing those animals to revert back to the wild? If we could get
because
all of our meat, if we could replace 100% of our animal products by not killing those animals and letting them live in the wild, what's wrong with that?
well, that's an uncontrolled population. I'll just say that. And
So what do we have to
most
do?
of those animals breed and reproduce at a much faster rate than humans do. So just think about that.
Yeah, but we wouldn't open the gates to the dairy field and just let all the cows go.
Where will you put them as they continue to grow? At some point, the gates are going to be, it's not going to be big enough to hold them.
Well, we have to ask the question, well, why do we have so many of them? So why do we have the number of dairy cows that we do? And the answer is to meet the demand of dairy products that we do.
Yes.
Dairy cows are artificially inseminated.
Yeah.
What happens when we stop artificially inseminating them?
Well, they'll breed naturally. They've been doing it for
That's fine, but
thousands of years.
not to the same number that we have.
No, but
Yeah.
regardless.
So then what's wrong with letting
the-
that smaller population just live in the wild?
Well, the math, it's just math. I mean, just think about the math. It might not happen as fast, but it's going to happen. So the bottom line is, and so we could talk about this for another hour, like
Yeah.
several more of our conversations. So I'm going to pop shoots right here, but just to let you know that none of this is in an argument against cultured food products.
Right.
In
That's
fact,
what I was getting at.
in fact, well, yeah, no, and I said that at the
I don't
beginning.
think I don't think it answers the question why we wouldn't want to not kill those animals.
Man, well, I don't know. Why would I not want to take a bath? I don't know what to say about that. I do have a couple of points I want to make, though.
Okay.
First of all, so one of the things you read talked about allowing animals to be in a much greater, more open space, as opposed to being cramped in a small place and controlled and antibiotics, et cetera, et cetera, et cetera.
Yeah.
So I'm not the guy that sits around and is, oh my gosh, we got free range eggs. Now I'm not just out there, oh, we've got to eat free range. We've got to eat free range. Cage free. Okay. So I don't do that, not because it's not a good idea. It's not my thing, but I do believe in, animals that are not packed in and my gosh, and people that are listening are going, dude, man, this is the most I've ever heard Dwayne talk on the podcast.
I knew this would get you going though.
Coach Lamby set him free. He's free. He'd be free. But so I talked earlier about stressors on an animal and what that can do possibly to the meat, tainting it with taste, et cetera, et cetera, et cetera. So there's no doubt. People will say, you're a liar. I can tell the difference between just a free range cow and one that is in a intense beef operation. And for people that have never seen pictures or have never seen, these cattle areas, cattle ranches and so forth that are just heavily producing beef. I'm not saying they're doing anything that's unethical. But it's, you've got a lot of animals and they're a lot closer together. Their stress levels are typically higher, especially chickens. That's a big business. Growing chickens is a big business. I'm not going to say whether I know a whole lot about, hormones and growth hormones and, developing the biggest chickens we can, et cetera, et cetera, et cetera. But again, you're putting chickens in a tight area where and I understand why they do it, but I don't think that meat is as nutritious, as tasteful, as consumable as a free range chicken. There's just, there is a different taste. Having said that, I also want to say this is that the average person in this conversation about, cultured meats or cultured food products, altogether. So, and this kind of goes from my bias as well, because I've never really thought about it. I'm going, ugh. But the average person, I don't think the average person understands, again, what the large meat markets are and what they look like and what those processes are, as well as just the things that you eat from your kitchen and how those things are developed, what kind of lab interaction is in those things. Maybe not even just meats or your well, we could talk about vegetables too, just in crop dusting and try and fight off critters as well as bacteria. But in the production of things that we put on our foods on a daily basis, Worcestershire sauce, which I love, hot sauces, salsas, pepper, salt, process of making oregano and different seasonings. If people really saw and understood the manufacture of some of that stuff, and I'm not an expert, so I'm not saying that, but just look into it. Just look into it. If you look at the ingredients on the side panel of some foods, you might be surprised what's in there. And that had to be worked out in a lab somewhere. So everything we're eating is not truly like, oh, we're just eating from the land. A lot of people work to do that, but you'd be surprised what you're sticking in your mouth. So cultured meat, I'm willing to give it a try. So
yeah, I think those are great points that rebut some of the arguments against cultured meat. So it would free up land, and if you really want to see more free range, pasture raised animals, and you would like to see more organically grown crops, both of those things require a lot more land use than the conventional methods of growing those. And so it would free up land in order to produce more of that. So being against it, but wanting more pasture raised animals and more organically grown, I don't see how those two align, and your points are valid arguments against, that rebut those arguments. So
right. Also want to say one more thing too, and if there's any farmers out there listening, or cattlemen even that are listening, I come from a family of farmers and cattle people, and so I'm with you. I understand your the work you do. I tip my hat to that. However, on the nationwide, at least in the United States, nationwide, there is a lot of money at play in how we do business in the food industry. So
yep, there's a heavy influence.
Yeah, just saying.
All right, well, let's cut this sucker off before it ends up being a 4-hour podcast. So fantastic topic. So thanks again to the listeners who are requesting topics to be talked about. So I had a good time doing this. I did too. Yeah, doing it. And so hopefully somebody gets something out of this. I hope I get my nasal cavity to relieve of its pressure at some day.
My mind has been blown, for sure.
All right. Yeah, that answers that question. All right. And everybody, we will see you guys next time. Lamby out.